in this next section, we're looking at something called linear modeling. It's just a fancy name of saying we're using straight lines, linear, and looking at practical situations. So there's a lot of real life situations where if we were to graph whatever's happening, it'll actually come out to be a straight line. Now, a couple of ways that we can go about solving these sorts of problems is one, we could find the equation of the line, and then we can use algebra in order to solve for the missing value. Another way is we may draw a graph and then solve it using the diagram. Okay, so both methods are fully acceptable, but you'll find that the algebraic method will usually give you a much more accurate result than you would if you were drawing a graph, and you'll see the next few examples here. So with our first example, I've given you a diagram. It's the number of songs that are owned by Kate over a series of months in her iTunes collection. iTunes a little bit old now. I suppose most of you are using Spotify and streaming music online as well. But back in the days, you actually bought songs or you collected songs as you went. So here's a graph. So we're looking at this straight line here. Yeah, and it's showing how many songs that Kate has over a series of months. So just note the variables on your x and your y axis are a little bit different, okay? And they're different so that when you're writing your equation, you know exactly what you're talking about. So if you're using x and y, then you wouldn't know which one was the number of songs, which one was months. So at the moment, we're using M for months and capital N for the number of songs. So the first question, find the gradient and the y-intercept of this line. Okay, and you can see that we've already drawn in a triangle here to work out rise over run, and that's what gradient is. So we're going to calculate the rise first. So it's starting at 400. Sorry, it's starting at 100 and it's moving up to 400. So the rise is equal to 300. Your run starts at 0 and then moves up to 20. So the run is equal to 20. So when we go about working out the gradient, it's rise over run. That's 300 over 20. Well, that's equal to 15. To work out the y-intercept, all we need to do is look at the diagram. The graph cuts the y-axis at the value of 100. So that means the y-intercept is 100. And that's part A. Part B, hence determine the equation of the line. So it's really important you know what the word hence means. Hence means that you're using the information that you've just worked out. Okay, hence means go to what you've just done and then use that in your next step. So we have our gradient and our y-intercept. So we're using y equals mx plus c. So when we substitute the values in, now remember our y and x values are now different as well. So we need to make sure we're using the correct pronumerals. So the y-axis was n equals, the gradient is 15m plus 100. Okay, make sure you do change the variables. Start with x and y if you need to, but make sure you're reading the graph carefully as to what pronumerals you should be using. All right. Part C, find the number of songs in the collection after 14 months. Now that we've got an equation, we can actually use the formula in order to solve these problems. So if I want 14 months, we used M for months. So if M is equal to 14, then we're substituting it into the formula. So N is 15 times 14 plus 100. Okay, so that was the formula that we had from before. And when we work that out, we get 310. Now, if we were to try work this out from the diagram, so at m equals to 14, and I draw a line up here, I can then bring that line across and approximate how much that would be. But the problem with that is it's not exactly on a grid line. So you're just saying, oh, it's going to be about this amount. Whereas if we've got an equation, we can actually work out a very accurate value there. All right, last one. How many whole months will pass before the collection exceeds 500 songs. So if we're looking at 500 songs, the 500 is the value of n. So n is equal to 500, and we're going to substitute it into that equation from above. So that's 15m plus 100 equals to 500. So what we're going to do is minus 100 across. 15m equals to 400. And then what we need to do is divide by 15. So minus 100, divide by 15. And we get m equals to 26.66 repeater. So we want to look at how many whole months will pass before it exceeds. So if we round it down to 26, we're not quite at 500 yet. So we need to round this number up. M is 27 months. Okay, so 27 months need to pass before we've got more than 500 songs. Okay, another type of question is one where you may need to draw your own diagram. So a computer was purchased for $1,200 and decreases in value by $180 every year. We're going to fill in this table of values and then draw the graph on the right. So at the beginning, the computer was worth 1,200, and then every year it's going down by 180. So if I take off 180 from 1,200, I've got 1,020, then 840, 660, 480, 300, 120, and then negative 60. So what we're now going to do is on our number plane, we're going to plot these points. Hopefully they end up being a straight line because that's what we're expecting. So at n equals 0, we've got a cost, the computer is 1,200. At n equals to 1, it's 1,000, so 1,020, so we're going to estimate that value. Then we've got 840, 660, 300, no, 480, 300, 120, and then at 7 it's going to be a negative value. So if I go and draw a line through that, the line's going to look approximately like that. Let me draw a bit longer. There we go. So that's going to be our line that will help us to model this information. So if I wanted to work out the cost of the computer at any other times, not the whole numbers, we can also use this graph to work this out now. Part B, we want to find the equation of this line. So to work out the equation, like before, gradient and y-intercept. So the y-intercept is easy. We can read that off straight away. It's 1,200. To work out the gradient, what we want to do is rise over run. What we can do is we can actually pick our triangle to be this part here, up to that point. So we know the horizontal is going to be 1 month, or 1 year, and the value has gone down by 180. Now remember, this line's sloping downwards, so that means the gradient is negative rise over run, 180 over 1, so that's negative 180. So if we're substituting into y equals mx plus c, okay, make sure you don't mix up the c for computer with the c of your y-intercept. So your y-axis is c, so c equals negative 180 n plus 1,200. Now another way we can write this is we can write this with the 1,200 first. So it's 1,200 minus 180n. Okay, both of them would be fine. Question C, use the graph to determine how much the computer is worth after 4.5 years and then check your answer by substituting into the equation. So if we want 4.5 years, we're going to go to 4.5 right here. We're going to draw a line up to the blue line. We're going to bring that number across, and we're going to find how much that is. So from this diagram, it looks like it's just under 400, but I think it's close enough to 400 that we can say using the graph, C equals 400. Okay, but what we can now do is we can check it using the formula we had. So when n equals to 4.5, C is 1,200 minus 180 times 4.5. And when we go to work that out, it's 390. So you can see that with the diagram, especially because if you're estimating the dots, it's not going to be completely perfect. So if you use the equation, you're going to get a much more accurate result than if you were just reading numbers off the graph. The last part, why does this model not make sense for values of n that are greater than 7? Well, even when it's equal to 7, what you would have seen in the table was that when we had the number of years equal to 7, we got a negative value for the value of the computer. Now, that's always going to be a problem. You can't have a negative value of something. So that's why this graph is really only valid up until that point right there, when the value of the computer is equal to 0. Okay, so we can say that the model doesn't make sense because the value of the computer is negative, and we can't have negative values. Value of the computer will be negative, and we can't have negative values. Okay, so it doesn't make sense to say, oh, this computer is worth negative $4 or something like that. So once it reaches 0, it's like it's not worth anything, and that's it. So there's a couple of other practical applications that you can have a look at in exercise 4J. Please have a go at those questions. And any problems, I'll see you in our Zoom.